Here's a model with brilliant offline numbers, 96% accuracy, a beautiful EUC, the best one the team has ever trained, and it will never be used by a single real person. A model that lives only in a notebook helps no one. The truth that almost nobody tells you is this. Training the model is the easy 10% of the job. Everything that takes it from that notebook to something the world can rely on. That's the other 90. So let's talk about MLOps. Start by changing one picture in your head. A trained model is not a file you save and forget. It's a loop. Watch it light up. Data flows in. You train. You track what worked. You package it. You serve it. You monitor it in the wild. And then, when the world shifts, you loop right back to the start. MLOps is the engineering discipline that keeps this wheel turning automatically and safely. We'll reveal one stage of it per chapter, and at the end, run a real model all the way around. Chapter 1. The Notebook to Production Gap. Here's the first stage of the loop, and the whole problem in one frame. On one side, a model that scores beautifully on your test set. On the other, a model actually serving live traffic. Between them sits a chasm, data pipelines, packaging, serving, monitoring, and crossing it is the real job. Hold on to this. Offline metrics are not production reliability. The hard part begins the moment training ends. And most models never make the crossing. An often cited figure puts it at around 87% that never reach production at all. Trained, promising, written up, and then quietly abandoned on a hard drive. Here's the part that surprises people. The reason almost never lives in the model itself. It's everything around it. The data that has to flow in reliably, the pipeline, the serving infrastructure, the monitoring that no one set up. That surrounding work is exactly what MLOps gives a name to, and it's where most of the engineering and most of the careers actually are. Chapter 2. Data and Pipelines. So we light up the first stage, data. Everything downstream inherits whatever the data is. So this is where reproducibility is won or lost. You snapshot the data, you version it, and you build your features with a pipeline. The same code running in training and in production. If you can't reproduce the data, you can't reproduce the model. Versioning is step 0. Watch how that works in practice. You pin an exact snapshot, say dataset version 3. A feature pipeline transforms it the same way every single time, whether you're training tonight or serving a live request tomorrow. That matters more than it sounds. If training and serving compute a feature even slightly differently, your model silently rots in production while looking perfect in the lab. Change the data, and the version label changes with it. That one habit kills a whole family of bugs, and finally ends the era of "it worked on my laptop." Chapter 3. Experiment tracking and the model registry. On to the next stage, training. But with a lab notebook bolted on. You will not train one model. You'll train hundreds of variants. So you log each one, its parameters, the data it saw, and the score it got. Do that, and you actually know what worked and why, instead of guessing. Machine learning is a science, and a science runs on a careful notebook. Tracking is what turns luck into knowledge. Look at the runs stacking up. Run 14, run 22, run 31, each with its settings and its AUC, all side by side. A tool like MLflow records every one of them. Then the winner gets promoted into a registry as a versioned model, version 1, something you can stage, deploy, and crucially, roll back if it misbehaves. The experiment becomes an asset you can trust. Chapter 4. Packaging and Serving. Now 2 stages light up together, package, then serve. The registered model gets frozen into a container, think Docker, carrying its exact Python version and libraries with it, so the same artifact runs the same way on your laptop and on the server. No more, but it ran in my environment. Then you expose that container behind an API, so other systems can simply ask it for a prediction. Package it once, and it runs anywhere. That container is the unit you actually ship. And serving comes in 2 shapes. Batch. Score a giant pile of data on a schedule, millions of rows overnight. Or real-time, wrap the model behind an endpoint that must answer in milliseconds, under heavy load. Picture a request hitting a predict endpoint and a score coming back in 40 milliseconds. Tools like Fast API or Bento ML do the same. The shape you choose drives the cost, the hardware, and the whole architecture around the model. Chapter 5. Monitoring and Drift. This is the stage almost everyone forgets, and it's where models die in silence. The gray curve is the world your model trained on. The accent curve is today's live data, and watch it slide away. No error is thrown, no alarm rings. The inputs simply drift past the model's boundary, and the accuracy quietly bleeds out. The code is fine. Reality moved. There are two flavors of this rot. Data drift. The inputs change. New users, new prices, new behavior. And concept drift. The rule itself changes. What even counts as fraud is different now. Either way, the model didn't break. The ground shifted beneath it. Which is why a deployed model is never finished. It's on watch. You track its inputs, its outputs, and its accuracy. Because the decay is invisible until you measure it. Chapter 6. Continuous integration, delivery, training, and the team. Now the final stage clicks in, and it completes the circle. Monitoring isn't the end of the line. It's the trigger for the beginning. The instant it detects drift, it fires the whole pipeline off again, on fresh data, validates the new model, and rolls it out, ideally with no human in the loop at all. See that red drift edge curving back to the start? That return path is the entire point. It's what makes this a loop and not a one-way line. Automate it. And the system starts to heal itself. And the automation has a familiar name, with one new letter. Continuous integration tests your code. Continuous delivery rolls it out, safely. Shadow it, send it a trickle of traffic, keep the old version warm to roll back in seconds. And continuous training, the piece unique to machine learning, retrains the model the moment monitoring sees drift. It's a team sport across data, engineering, and operations. And together, they keep the flywheel turning on its own. Chapter 7. An incident. Live on the loop. Now let's run the loop, live, and walk through a real incident. The fraud detector is in production, happy at 96%, until the world shifts and the live accuracy starts to sag. Watch the number fall. Nobody filed a ticket. Monitoring catches it first. As the accuracy crosses the threshold you set, an alert fires automatically on the monitor stage. And here's the beautiful part. That alert doesn't just page a human at midnight. It pulls the red drift edge and kicks the pipeline off again, retraining on fresh data that includes everything that changed. The token re-enters at data and moves through train, with no one touching a keyboard. The loop is healing itself, in real time. But a freshly retrained model is a guess until it meets real traffic. So you never swap it in all at once. You ship it behind a canary. Version 2 goes live to just a sliver of users, say 10%, while version 1, the proven model, still serves everyone else. Then you watch the canary's metrics against the old version, side by side, and in this incident, version 2 comes in worse. So the system does exactly what you'd hope. It halts the rollout and snaps every request back to version 1 automatically in seconds before most users ever notice anything was wrong. That safety net, a small blast radius, and an instant rollback is what lets you ship boldly. Because a bad model can't take production down with it. Chapter 8. One model. All the way around. Let's put it all together and trace one real model around the entire loop. A fraud detector. Version transactions flow in at data. At train, the best run is found, its parameters and score logged. At track, it's promoted to the registry as version 1. At package, it's built into a container. At serve, it goes live behind a low latency endpoint. And then at monitor, drift is detected. So it loops back, retrains, and redeploys. Watch the token complete the circle. That is a model in production. So step back and see the shape of the whole thing. The model really was the easy part. Version the data, track every experiment, register the winner, package it, serve it, and watch it for drift. Then automate the entire wheel so it turns without you. Hold that loop in your head, and you can take any model out of a notebook and into something the world can genuinely rely on. That's MLOps. That's where the real engineering lives. The model is 10%. The loop is the job. Subscribe for more such intuitive videos.